So looking at this first page, it's kind of like a what to do 101. To do compounded interest, we have two different formulas. So we have this one, and then you use this one.
It's blurry. Wait, which one?
So you have to know these formulas.
Okay.
For compounded interest. When it's continuous, you use your PERT formula. For graphing, you're going to have to know how to find the domain, range, vertical asymptote, horizontal asymptote, x-intercept, y-intercept. So when it's an exponential graph, your domain is what?
All real numbers.
All real numbers, negative infinity to infinity, or you could put all real numbers. Do we have a vertical asymptote here in exponential graphs? No, so this would be none.
Oh, I love my calculator.
So now our domain, our range and our horizontal asymptote go hand in hand. If we don't have a shift, a vertical shift in our graph, it will be 0 to infinity, and our horizontal asymptote will be y equals 0. This changes if there's a shift up or down. So changes with shifts up or down. And it changes with that shift. So if I had 3x plus 4, my graph is going up 4, so my new range would be from 4 to infinity. And my horizontal asymptote would be y equals 4. So your range and horizontal asymptote change with a shift up or down. X-intercept. Do we have an x-intercept here? No.
Should be 0, 1.
The y-intercept, how do we find the y-intercept?
Set the top in the parentheses.
Plug in 0 for x.
Are you going to go over this on Monday too?
All right, for logarithmic functions, let's say I had something like log base 4, and then in parentheses, x plus 3. My domain is based off of this number. So to find the domain, you set the parentheses equal to 0, and then it goes to infinity.
So negative infinity.
So it'd be negative 3 to infinity for this example here. Negative 3 to infinity. So you set the parentheses equal to 0. What's my range? All real numbers. How do I find my vertical asymptote? Set the parentheses equal to 0. So same thing, vertical asymptote and domain go hand in hand. Whatever this number is, it's going to repeat here. And it's always going to be x is equal to whatever that number is. So here x would be equal to negative 3. I have no horizontal asymptote. How do I find the x-intercept?
Set the parentheses.
Plug in 0 for y. And then the y-intercept, there is none.
All real numbers.
Domain for exponential functions are all real numbers. Now before I find my range, I'm going to graph it first. So I'm going to graph by plugging in numbers. How do I know what numbers I should plug in?
Start with 0. Whatever would give you.
I start by setting this equal to 0, because that'll give me a good idea of what number I should plug in the middle, and then I'll plug in something smaller and something bigger. So I have negative 2x plus 1 equals 0. Subtract 1, so negative 2x is equal to negative 1. Divide negative 2, x is equal to 1/2. So 1/2 is going to be my middle number that I plug in. What's a number smaller than 1/2? 0. And a number bigger than 1/2? 1/2 is 1. If you wanted to plug in more numbers than that, that's totally fine. Plugging it in just helps you get the shape. So this graph could look like this, or it could look like this. I'm going to plug in numbers to see what my graph looks like. So first I'm going to plug in 0. So I have 1/3 times 2/3 to the power of negative 2 times 0 plus 1. So this is 1/3 times 2/3 to the power of 1. And 1/3 times 2/3 would be 2/9. 2/9. So my graph, I'm going to stay at 0, go up 2 over 9. So I'm going to make my spaces kind of large here because these are going to be fractions. Stay at 0, go up 2 over 9. So about there. Yes. 2 over 3.
Yeah, I thought it was 2 over 5.
It's the 3. Sorry. All right, so next I'm going to plug in 1/2. So I have 1/3 times 2 thirds to the power of -2 times 1/2 plus 1. -2 times 1/2 is -1. -1 plus 1 is 0. So this is 1/3 times 2 thirds to the power of 0. What's 2 thirds to the power of 0? 1. So this is 1/3 times 1, which is just 1/3. So I'm going to go to the right 1/2 and up 1/3. It's about there. Then I'm going to plug in 1. So I have 1/3 times 2 thirds minus 2 times 1 plus 1. So this is 1/3 times 2 thirds to the power of -1. What does the exponent of -1 do to the 2 thirds? Flips it. So instead of 2 thirds, it becomes 3/2. Now you multiply straight across. So this is 3 over 6, which is 1/2. So I plugged in 1 and got 1/2. So the next point would be at 1 and up 1/2. So my graph is going to look like this.
You're like plugging the number into the whole equation.
Into the x in the equation here.
Not just like the one on the
Right.
exponent thing.
Plug it into the whole thing. Now remember my range and my horizontal asymptote change if I have a vertical shift. Am I adding any number out here? No, so I don't have a vertical shift. So what would my range be? 0 to infinity. And what's my horizontal asymptote? Y equals 0. So because I'm not adding anything out here, it's 0 and 0. If I had like a plus 2 out there, my range would be from 2 to infinity, and my horizontal asymptote would be y equals 2. So it only changes if you have a vertical shift. So if you move it up or move it down. How do I find my y-intercept? Plug in 0 for x, which I already plugged in 0 here actually. So when I plug in 0, I get 2 over 9. So how would I write that as a point? 0, comma 2 over 9. And on the test, you're not going to have to name the transformations, but it will list everything. So it'll say domain, range, horizontal asymptote, y-intercept, x-intercept, and vertical asymptote. Do I have an x-intercept here?
No.
Nope, so none. Do I have a vertical asymptote here?
No.
None. So for example, if I had one that was like 1/3, I'll just make the same one, to the power of x plus 6 out here. My range would be from 6 to infinity, and my horizontal asymptote would be y equals 6. So this number that you're adding or subtracting at the end determines your range and your horizontal asymptote. Any other questions on the exponential one? All right, let's look at the log. Yes. So in graphing logs, the first thing I want to do is find my vertical asymptote and my x-intercept, because that'll give me my vertical asymptote, that dotted line. My x-intercept is a point. So I'm going to do the vertical asymptote first. How do I find my vertical asymptote? Set the parentheses equal to 0. So I have 2x minus 7 is equal to 0. Add 7 to both sides, divide by 2, x is equal to 7 over 2. So my vertical asymptote is x is equal to 7 over 2. So on my graph, that's going to go to the right 3 1/2. So there's my vertical asymptote. Now how do I find my x-intercept?
Plug in. Well,
You, I don't remember.
you.
Plug in 0 for y. So I'm making this 0. So 0 is equal to log base 2 times log base 2 of 2x minus 7. Now yesterday we learned how to solve log functions. How can I get rid of that log base 2?
Base 2.
Make my big base 2. So I have 2 to the power of 0 is equal to, this cancels out, so 2x minus 7. What's 2 to the power of 0? 1. So 1 is equal to 2x minus 7.
X equals 4.
Add 7 on both sides. So 8 is equal to 2x. X is equal to 4. So how would I write that as an ordered pair? 4, 0. So I'm going to go to the right 4, stay on 0. That's my x-intercept.
So then do you have your domain too?
What's my domain?
4 is
Remember, domain goes with vertical asymptote. So it starts with the same number as your vertical asymptote. You set the parentheses equal to 0. So 7 halves to infinity.
and then your range is all around.
My range is all real numbers because it's always all real numbers in log functions. And then when graphing, just make sure you know what a log graph looks like. So you don't have to plug in any more points. Just know that our log has this shape. If you had a negative log, so let's say negative log base 2, we'll do this, we'll just say x. Here, our log would have, since it's negative, it reflects on the x-axis, so instead of having this shape, you flip it and it would have this one. So a negative log just goes the opposite way. So your log just has this shape, so make sure you have the shape and your y-intercept. So you only need 1 point for your log functions. All right, so looking at 7. Awesome. So I need to find my domain, range, vertical asymptote. It's a log function, so it's not going to have a horizontal asymptote, and it's going to have an x-intercept with no y-intercept. 7. How do I find my vertical asymptote? Well, if there's no parentheses, then it's just the x. Because there's nothing else happening in that. So set the parentheses equal to 0. So my vertical asymptote is going to be x equals 0.
Oh, X, sorry.
So what does that mean my domain's going to be?
0 to infinity.
0 to infinity. Because your vertical asymptote and domain go hand in hand. That same number is going to repeat for both of them. So my dotted line is going to go through 0. What's my range?
All around.
All real numbers. Now I have to find the x-intercept. How do I find the x-intercept?
Set Y equal to.
Set y equal to 0. So 0 is equal to negative log base 10 of x minus 6. So I'm solving for x. So I want to get that log all by itself because then I know how to get rid of it. So what should I do first? Add 6. So 6 is equal to negative log base 10 of x. Then what should I do?
Can you multiply that negative?
Yep, I'm going to divide both of these by a negative. So negative 6 is equal to log base 10 of x. How can I get rid of that log base 10?
10. Big base 10.
Make my big base 10. So that cancels. So I have x is equal to 10 to the power of negative 6.
So that's 1 whatever.
So it's x is equal to 1 over a million. So it's really, really small. So my x-intercept is 1 over a million. Sure, if you know how to put that on your graph, definitely. But that works. No. All right, so this point's going to be super duper close to our horizontal or vertical asymptote. Now our typical log graphs have this shape, but looking at our reflections here, or our transformations here, this negative outside makes it what? This makes it reflect over the x-axis. So instead of going like this, it goes the opposite way. So it starts down here and goes that way. So that's our graph. All right, so let's take a look at 24. 24 is one of those that makes you think a little bit.
And then can you do 26 after?
Yeah. Okay, so here, I'm gonna add the negative x times e to the power of negative x. So I'm adding this to both sides. I'm gonna rewrite it here so we can see. So it's e to the power of negative x is equal to, I'm adding this to go to the other side. So x times e to the power of negative x.
Wait, what?
I just added this to both sides. Just because I can take the ln of both sides and get my e's to cancel.
So you have plus
So I'm just moving it to the other side.
plus xe minus
Wait,
x to the
don't
other
tell me
side.
this. And then you divide that and
So
you
you did?
I think that would work, but I'm gonna do it a different way. But I think that works also. So I would take the ln of both sides, because the ln of e to the power of negative x is what? What happens to the ln of e? Cancel, so it's just negative x is equal to, here, I have ln of x times e to the power of negative x. So when you multiply, how do you expand them? Add them. So this is ln of x plus ln of e to the power of negative x.
My brain can't process this. I don't know.
So ln of e cancels, and we're just left with negative x here, but it's ln of x minus x. Can I combine any like terms?
Yeah.
Add x. So this becomes 0 is equal to ln of x. How do I get rid of that ln?
Divide.
Make my big base e. So it's e to the power of 0. 1. And then this cancels, so 1 is equal to x. So Geo, yeah, the way you said would have worked too. Was that we could have taken from this step, so e to the power of negative x is equal to x times e to the power of negative x. I could have divided both sides by e to the power of negative x. These are the same, so it becomes 1 is equal to, and these cancel out x. So that works too.
Wait, can you do 26?
I'll do 26 next. For 19, 3 to the power of x is equal to 81. Can I make 81 look like 3 to some exponent?
4.
3 to the 4th power. So if both of my bases are 3, they cancel, so x is equal to 4. I'll do 21 also. So if I have log base 7 of x is equal to 3, how can I get rid of that log base 7?
Big base.
Make my big base 7. So then this cancels, so I have x is equal to 7 to the 3rd power. 7 to the 3rd power is 343.
Yeah.
So that's my answer. All right, let's look at 26. So first thing, I'd probably, so 2x ln of x is equal to x. Just added it. I can divide both sides by 2x. So ln of x is equal to 1/2. How do I get rid of that ln? Make my big base e. So then this cancels, so x is equal to e to the power of 1/2. And then you can just put this into your calculator. So what's x equal to? 1.649. So for log base 7 of 7 cancels, so your answer would be negative 0.89. So let's take a look at number 5.
Is that just calculated?
What happens to ln of e? Cancels.
And this time, please allow the cross-country team to be released.
So we're left with 4.6 times 2, which would be 9.2. Number 2. You want to see it?
I want to see the part where you set it equal to 0. Like I'm still
So x minus, we set the whatever's directly happening to x equal to 0. And that's going to give us our middle number to plug in.
And then don't you set the equation equal to 0 as well, like the whole equation?
No, right?
No, because this one, you wouldn't have to find the y-intercepts. You just have to find you wouldn't have to find the x-intercept, but you have to find the y, so you plug in 0 for x. But you wouldn't set the whole thing equal to 0. Because in order to solve that, we would need our calculator.
Like this would be like a graphical, like you just do the top part and take your middle number and then.
Yeah. So we'd want to plug in 1 and 3 also.
But into the whole equation.
Into the whole equation, so into this whole thing. So setting the top piece equal to 0 just helps you find your middle number in exponential ones. Alright, so I'm going to do a couple more questions on this page and then do a few more from the extra practice as well. So looking at 14, here we are asked to expand. So we have the ln of 5 square root x over 6. So here we're multiplying and we're dividing. So when you multiply, you use addition. So this would be ln of 5 plus ln of square root x. And then when you're dividing, you subtract minus ln of 6. We have to change the square root to be an exponent. So the square root of x is the same thing as saying x to the 1/2 power. And then we know when we have a power, we move it in front of the ln. So this would be ln of 5 plus 1/2 ln x minus ln 6. Great, I'm going to do a condensing one down below. So number 18. Here we are subtracting, so that means we're going to divide. And we are adding, so that means we need to multiply. It's important here that what you're multiplying gets multiplied on top, and what you're dividing goes to the bottom. So this ln, the 2x minus 3, wouldn't stay on the bottom because then that would mean we're dividing it as well. So this would be here. ln on top, we have x times 2x minus 3. And then on the bottom, we would have x plus 2. So it's the ln of all of that. I'm going to do a couple more of the solving ones just for practice, because the more you see, the more you practice doing them, the easier it becomes to see what you need to do to solve. So looking at 22, to get rid of the log, I would need to make my big base 10 on both sides, so it'll cancel out. So I have x minus 4 is equal to 10 to the 5th power. So x minus 4 is equal to, one more 0, there we go, 100,000. So then we add 4 to both sides. X is equal to 100,004. Alright, and then looking at 23, I'm going to do it on the side over here. So I have 1,025 divided by 8 plus e to the 4th power x is equal to 5. I want to get that e out from the denominator, or I guess the x out from the denominator, so I'm going to cross multiply on both sides. So this is like 5 over 1. So it'll be 1,025 is equal to 5 times 8 plus e to the 4x power. I could distribute, but I don't really want to because my goal is to move that 5 to the other side and just get e all by itself. So I'm going to divide everything by 5. So it'll cancel. So this would be 205 is equal to 8 plus e to the power of 4x. Subtract 8 from both sides.
So 197 is equal to e to the power of 4x. To get rid of that e, I need to take the ln of both sides. So the ln of 197 is 5.2832. Keep it in your calculator to get the most precise answer. The ln of e cancels, so this is 4x is equal to, so divide 4 on both sides, you'll get x is equal to 1.3208, which would round up to 1. And then the last one I'm going to do on this page is 25. So I want to condense this to 1 log, that way I can cancel it out. So I have the log base 10 of x. Since I'm subtracting, that means I have to divide. So this should be an x up top. So it'll be x divided by 8 minus 5x is equal to 2. So make my big base 10 on both sides, so this will cancel. So you make the big base whatever your little base is there, that way it'll cancel. So you have x over 8 minus 5x is equal to 100. I'm going to cross multiply to get rid of that fraction, so this is like 100 over 1. So I have x is equal to 100 times 8 minus 5x. X is equal to 800 minus 500x. Combine like terms, so I'm going to add 500x to both sides. So this would be 501x is equal to 800. Divide by 501 on both sides. So 800 divided by 501 would be x is equal to 1.596, which is 6/8, so it would round up to 7. All right, looking at some ones on the next page, I'm going to do a graphing one. So 38, this is log base 5 of x minus 3. So log base 5 of x minus 3. So since this is a log function, we know it's going to have a vertical asymptote, and the vertical asymptote and the domain go hand in hand. We also know that our range is going to be all real numbers, and we are going to have an x-intercept here, because our basic log functions look like that. So they cross the x-axis. So to find our domain and our vertical asymptote, we have to set what's inside the parentheses equal to 0. So this would be x minus 3 equals 0. Add 3 to both sides. X is equal to 3. So that's our vertical asymptote. I'm going to graph it over here. This is just an example of a basic log graph. If we didn't have any transformations, our log graphs has that shape. Here, our vertical asymptote goes through 3. So 1, 2, 3. There's a vertical asymptote. So that means our domain is going to be 3 to infinity. And then to find our x-intercept, we would set the whole thing equal to 0. So we set y, replace y with 0. So we're setting the whole thing equal to 0. So I have 0 is equal to log base 5 of x minus 3. To get rid of that log, I want to make my big base 5 for both sides. So 5 to the power of 0 would be 1. And 5 to the power of log base 5 cancels. So 1 is equal to x minus 3. Add 3 on both sides. So 4 is equal to x. So my x-intercept, I plugged in 0 for y and got 4. So my graph here, I'm going to go to the right 4, put a point. And then I don't have any reflections or anything, so my graph here is going to have that basic log graph shape. So it's going to get close down here and then get farther away out here. So that's all you have to do to graph log functions. Next, I'm going to go down here, do some more expanding and condensing ones. So looking at 71, here we are expanding. So I have x plus 3 on the top. This is one term, stays together. And then on the bottom, I'm dividing and multiplying x times y. So I have ln of x plus 3. Then I have division going on, so this would be minus everything on the bottom, so ln of x times y. When I split this up into addition, because I'm still multiplying here, I have to make sure I subtract both of them because this minus applies to everything that's on the bottom. So it would be ln of x plus 3 minus ln of x minus ln y. So everything that's on the bottom gets a minus, a subtraction sign. All right, I'm also going to do 72. So here I have ln of x times y to the 5th power divided by the square root of z. So since I'm multiplying on the top, I know I'm going to separate those and add them. So ln of x plus ln of y. It's y to the 5th power, so I can move that 5 up top here out front. So that would be a 5 there. Oops. I'll erase this, because I moved that 5 to the front. And then next I am dividing, so minus everything on the bottom, so that would be ln of z, the square root of z, which the square root is the same thing as the 1/2 power, so I would bring that power to the front. So that's my answer for 72. Now let's take a look at 76. Here I'm condensing to 1 log. So first thing I want to do is move my numbers out front, up top. Sorry, that was my dog. So then I have ln of x minus 2 to the 5th power minus ln of x plus 2 minus ln of x cubed. Everything that I'm subtracting is going to go on the bottom, so this will be ln of x minus 2 to the 5th power over x plus 2 times x cubed. And it's the ln of all of that. Now let's look at 77. So again, I want to bring those numbers that are multiplying out front up top as exponents. And then when I'm adding, I just multiply. So this will be the ln of 3 times 4 minus x squared to the 1/3 power. So you could write 1/3 power, or you can say the cubed root, same thing. And then it's being divided by x. Since this is subtraction, you got to divide. All right, let's take a look at 95 also. So here we're solving. So I have 3e to the power of negative 5x is equal to 132. You always want to get that e, or whatever the number is with the x and the exponent, or if it was a log or ln, you want to get that all by itself. So first thing you want to do is divide by 3. So this is e to the power of negative 5x is equal to 132 divided by 3, which is 44. To get rid of that e, we need to take the ln of both sides. So this will cancel. So I have negative 5x is equal to the ln of 44. I would put the ln of 44 in my calculator. So negative 5x is equal to 3.784. I would suggest keeping it in your calculator to do the rest of the math, just so your answer is as exact as possible. So then just divide both sides by negative 5. So x is equal to negative 0.7568, which 8 would make the 6 round to a 7, so 5, 7. Okay, and then I'm also going to do 111. So we're solving again here. So we have log base 4 of x minus 1 is equal to log base 4 of x minus 2 minus log base 4 of x plus 2. So I know if I have a log on one side and a log on the other, they're going to cancel out. So I want to condense my right side to just be one log. So the left side is going to stay the same, log base 4 of x minus 1. And that's going to be equal to log base 4. Since we're subtracting, I can condense by division. So x minus 2 over x plus 2. And then since I have the same logs on both sides, I can cancel them. So x minus 1 is equal to x minus 2 over x plus 2. I would need to solve for x from here, so I'm going to cross multiply. So x minus 1 times x plus 2 is equal to x minus 2. On the left side, I'm going to have to FOIL, so x squared plus 2x minus x minus 2 is equal to x minus 2. Combine your like terms, so on the right side, this would become just x, and then I'm going to subtract x on both sides, so this actually cancels, and I'm going to add 2 to both sides, so this cancels as well. So now I get x squared is equal to 0. And if you take the square root of both sides, you get x is equal to 0, and that's your answer. However, it's super important that we check for extraneous solutions when we have log and ln questions. So we would just take our answer, plug it into the parentheses here, here, and here. If you get a negative in one of those parentheses, you cannot take the log of the negative number, so that would not be an answer. So here we would have, so when I plug in 0 into x minus 1, this would be 0 minus 1, which is negative 1. So 0 would not be a solution because you can't take the log of a negative. If you put the log base 4 of negative 1 in your calculator, change it base formula would be log of negative 1 divided by log of 4. If you did the log of negative 1 in your calculator, you would get error message or no solution or does not exist or something like that. So it would not work. So 0 does not work. So here this would be no solution.